Hi everyone, so welcome to another weekly presentation. So today I'm going to talk about temporal tables. I know that some of you have already worked with this, but shall we just see who is familiar with temporal tables? No one? Ravin is shaking his head like he's hearing it for the very first time. Okay, anyway, it's cool. We'll go through temporal tables and see what it is and how we can use it for our development. So here's a quick introduction to temporal tables. It's not a new concept. It's been around for a while. It's just that it's new to SQL, MS SQL. So it was actually introduced in 2011, and IBM and Oracle. IBM and Oracle are some of the early adopters of temporal tables. So it basically keeps track of all the changes in a particular table, right? So if you do a change in any given table which you have specified as a temporal table, it will basically do the change tracking, like for auditing purposes and many other reasons. And also it obviously due to that it provides a mechanism to query historical data. So if you want to go back in time and see what the data was like back then, you can do it with temporal tables. And also the another cool thing about this is once you define a table to be a temporal table, it need not be the case all the time. You can enable and disable this feature at any given time. And now it's an inbuilt feature with SQL Server 2016, so which is great for people who are using SQL Server because it will reduce a lot of their effort. So you will see what I mean at the demo. So it's commonly used how to understand data is being changed over time. So it's basically you have to always think when you are using temporal data, you're always dealing with time. So it's always got to do something with time and how the data changes over time. And also to do historical querying, like I mentioned, with temporal tables, it's pretty easy to do querying for historical data, which we cannot do in regular tables. And also to analyze data if we actually need to do such a thing. To implement and maintaining slowly changing dimensions. So these are some of the concepts which are used in data warehouse. So I'm not going to go deep into these things, but I will look into some things which we can adapt to our implementations. And also, if we mess up the data by any chance, we can revert it back to a last known stable state with this. So here are some popular usages, like I mentioned, data auditing, point-in-time analysis, meaning something like traveling back in time, and anomaly detection means if you want to see if there is any unusual activity or unusual behavior in your data, you can do that as well. Slowly changing dimensions and repairing row level corruptions. So how it actually works is, it's nothing big like for us. So we have a normal table which is our temporal table, and if you forget about the old versions and the history table part, so usually when we have a regular table, we do the update, delete, insert and whatever. What temporal tables does is, if you specify this regular table as a temporal table, it will automatically have a history table to keep its versions. So we don't have to worry about maintaining the history table or anything like that. It's something which SQL Server does for us. So that's how it goes. So when querying the data, it will either query from this table or the history table, or it will be a combination of both. So at any given point, the regular table, or in this case the temporal table, will have the current data. It will not contain any history data, it will contain the current data, and whichever older versions will be in the history table. It's pretty clear, right? Does anyone have any issues up to now? It's kind of simple. Okay, so there are a couple of ways we can do this. One is obviously we can create a table from the very beginning and define it as a temporal table, or we can modify an existing table and specify that as a temporal table. So when it comes to querying, it is actually SQL, the normal SQL insert update queries which we use in our work. It has like one or two extra syntaxes, new syntaxes which you have to use if you want to query older data. So it's very familiar. I don't know, when I went through this, I didn't find it that difficult to understand or anything, because it's very familiar to what we are used to at the moment. So let's quickly get into a demo. So let me create a database. So I created this just now. So what I'm going to do is I'm going to create two temporal tables. So I have already written the queries before. I will explain. So one thing with temporal tables is you can see that there are like these three lines, it's repeating. So it's something mandatory which you need when you are creating a temporal table. So you need a start time, end time, and you have to define a period column. So how it works is it will actually it will have the main data in the main table, and in the history table it will be a record of at what time this particular record was validated. So it will be a period of time. So let's say today I go and enter some data to my regular table. So then it will automatically set the start time to the today's date, like date time which you actually entered it, and the end time will be the max value, I think 999, something like that. And then if I come tomorrow and if I change something in that row, it will record a new entry in the history table, and for that for that history record, the start time would be today's date, and the end time would be the time I modified it. Alright, so the if you go back to the normal table and check, it will only contain the current information. So we'll see that. I just wanted to explain what these three things were, and also we have to switch on the or enable the system versioning for these tables. So here I am creating two tables. One's called department with anonymous history, and the other one is called department with default history. So if we don't specify anything about the history table, it will create you a default history table. So we'll see how that looks like. So I have a very simple table. It has a department ID, department name, manager ID, and parent department ID. So those are the information which are relevant to me. The others are purely for history tracking. So I'm going to execute this one. So now you can see that my table is created here, and unlike a regular table, we have this little clock icon here. So indicates that it's a system versioned table. And now if you go into this, you can see that there is another table here. Okay, so this is what will be generated if you don't specify any information of the history table. So this is like a template. So MSSQL underscore blah blah blah, and this number is the object ID of our parent table. Okay, so that's just to name this history table. And let's have a look at the columns. So I will collapse this one for now. So we are in the department with anonymous history table, and let's have a look at the columns. As you can see, I specified 7 columns. So department ID, department name, 6 columns, manager ID, parent department ID, and these 2 things. So for these to work, what do you guys think the history table should contain? Any guesses? Sorry? No, I mean, triggers, columns.
All the columns from each table plus another column for each history table as a primary key.
Okay. So Ravin is kind of close. So what it will do is it will basically have exact same thing. It should have the exact same thing, otherwise it will give you an error because there's no point of tracking, right? So it should have the exact same schema there. Now one of the things now I'm going to actually discuss, so you guys can take part in it, don't just listen. So one of the things with this is now there are some restrictions. So every feature has its own limitations. So you cannot create a temporal table for any table without a primary key. So as you can see, I specified this to be a primary key. So I cannot have I cannot specify a normal table without a primary key as a temporal table. But if you go here, you see that it's not there because it's irrelevant to this history table. Okay, so it's just keeping track, and we can't go and modify these things as well. Okay. Are you guys clear? We are still in the schema state. So.
Are there any triggers created?
No, there is an index created.
No, the original table are there triggers?
I think right now, so if we had to implement something like this, we would go with something similar, right? We would have 2 tables, and we would probably have written some triggers to our original table to go and record things in the other table. So it's something like this, just that all the maintenance and probably performance wise also they have handled it internally.
Now if you add a new column using the management studio code, we can take the column table.
Yeah. So we'll counter that later. Okay. So I'm still in the process of creating this table. Okay, don't. Okay, so it's like this. Now let's say I enter a record. Collapse this for now. So I enter record to this department with anonymous history table. So for now, let's simplify this and we'll say we only have an ID column and a name column, right? So today in the morning at 8 a.m. I'm going to enter ID 1, department name, I don't know, HR. Okay, so that will be my first record to this table. So then what that means is that particular record is valid from 8 a.m. today in the morning till.
So like do we have to pre-fill this start time and
No.
time?
So
Insert.
no. So usually what I have read is usually now I wanted you guys to see this, that's why I added it here. Usually they defined it as a hidden column. So when it's hidden, you don't even see it here. I'm not sure. Yeah, you don't even see it here, I think. And anyway, then you don't have to specify values at all when you insert. So it automatically detects whatever the time you are going to enter. And it's like these 2 columns are basically telling you from which time to which time this record was valid.
So then the same thing will be copying to the history table.
Not when you insert, but if you go and update it, like now I entered ID number 1 and HR, and if I rename it to HR department like 1 hour later, then it will have a entry in the history table for my old version, which is ID number 1, name HR, and then the valid time will be, start time will be 8 a.m, end time will be 9, because I changed it at 9. In my new, in the in this main table, my record will be 1 and HR department.
So the main table will only have the start time, right? So it won't have the end time.
It will have a default
End time,
max
it doesn't
thing.
matter.
Yeah, it doesn't mean anything. It means valid from today onwards. So. Now this looks a bit ugly. This name. So what you can do is you can even give your own history table name. So in this second example, what we are doing is it's pretty much the same, except I am defining my history table name. So now when I execute this, it will give me another temporal table, and only difference will be the history table name will be what I have specified here. Okay. So when specifying the history table, you have to give the schema name. It doesn't do any smart thing like creating it in the same schema, blah blah blah. That's not there when you are specifying a history table. So you have to give the schema name. But in the previous case, because we didn't specify anything at all, it went ahead and assumed that I should create this in the same scheme. So let's execute this and see. Everything else is the same here. Only difference is this one.
What is that period for system, right?
Yeah, it's like a constraint hetu. Like it means it's a period column. So it's saying that this from this time to this time sort of a thing.
Are there any other constraints like that in addition to system values of type?
You can specify your own things, but for the temporal tables, these are the only things you need.
So if you don't have the column names exactly like that, it is error.
No. Names you can change. These things you can change, and you will have to put it here.
Right.
But these three things you will need. If you don't have these three specified, it won't let you create. So shall we actually see that? Otherwise you guys won't. So I'll just because I already created this table, I'll just rename it to 1. Sorry? I can't drop it directly also, there's another thing for that, so I'll just do it this way. Now
Key.
So if I just execute this part, it will give me a normal table. So the only thing extra which I am doing here is I am specifying this as a system versioning table and specifying a history table. So it will give me a error. It won't let me do that because there is no point of creating a history table without the periods. Are you guys okay? Okay, so now this is the other thing. So I previously executed this one. So now you can see I don't have that long name for the history table. It has taken the name which I have specified, and everything else is the same. So what you have to keep in mind is, now if this table which you are specifying, the history table which you are specifying, if it's already there in the schema, then you have to make sure that the the table schemas, they match the designs, the columns and everything. If not, it will give you another error. It will just say that it doesn't match, and it will not let you create at all. Then we'll see how we can modify an existing table and make it a temporal table. So this is the script for that. And what I'll do is I'll create a table and call it department. So it will have ID and name. So I'm not going to specify a primary key for this. It should not let me create this at all. Okay. So you can see it's there, and it doesn't have any history thing on it. This is just a regular table. So now here what we are doing is, for the department table, we are going to add in our 2 columns and specify them as a period. And then after that is done, I'm going to enable system versioning and specify what's my history table. Okay. So I'll just rename this one. So it should give me an error because I have not specified a primary key. So let me go and do that quickly. And now it should execute. So now it's giving me the error because this part was executed before. For this to execute, it doesn't need the primary key. Only for this part you need the primary key. So this is where we specify this table as a temporal table. So now it's all good. And if I go and see, now it's a system version table, and I see my history table here as well, and the columns are also there. Okay. So let's move on to the other scenario. So I think Hetu asked what will happen if we go ahead and change the design of the tables. So you can just do it to the your regular table, just like you do every day, and it will automatically do the same for the history table as well. So here what I'm going to do is I'm going to change the department table. So my name is nchar10. I'm going to alter that column to varchar 100, and I'm going to add a new column as well called manager name. So we'll quickly go to the history table and see how it looks like. So it just has an exact copy of the same thing there, right? So we don't need to worry about the history table. When we change this one, it should automatically be handled. So my new column is there, and this is changed. And if we go here, you can see this is changed and the new column is added. So these are the benefits of having a temporal table. So less maintenance, and it's kind of neat. Like you only have to actually worry about one table, and SQL Server will take care of the rest of it. Okay, does anyone have any questions after this?
Yes, can you actually check the table so that create a temporal table directly without writing a TSP?
You mean modify?
Can you automatically create a new table with the temporal table?
Oh yeah, that's what I did before.
No, but
from
the table, right?
From the UI you can have. So there is a thing called, I'm not sure whether my, so I saw it somewhere, but no, there is a option called, I think I saw it in Azure, I'm not sure. No, wait. So there is an option. So when you go to create new table, it says there are a couple of options like system version table. So this falls under that. So some older versions of SQL Server, system version tables are not. They are not a new concept. They have been there in older versions. So this is how. Yeah. So here you can't just create stuff. So it will give you the query window, and it's the same script. Okay. So then, anyone else? Okay, right? We are still doing like very small stuff. So now let's go and insert things to our table. So I will be working on this department table. So I just wanted to stress that this is nothing like, I mean, even though there's a lot of things happening behind the scenes for us as developers, it's not a major difference. Like there are certain things you need to do in order to maintain this properly, but when it comes to most of the things, there are things which we are familiar with, so we don't need to worry about that. So now I'm going to insert values to my department table. Why is it?
No, I think this was open
Before I created the table.
Okay.
Okay. So now I'm going to insert some data to my department thing. So first let's do this without specifying the column names. So ideally, I think I added something new here. So we have manager name as well. So I'll just specify something here.
What is the color for that?
The daytime tutorials size is huge. The auto from you created 7. Yeah, 7. Sorry. 7. Just insert. Not sure if you calculate. Can't track the time.
Can't remember.
You have 0 here. Anyway, let's execute this.
So now because I have specified in my table these two to be hidden, I don't need to give the values here. So this should be fine. So it's like for us as if we are only entering data to the values which we already really care about. So this should enter data, so it did. And let me have to select query here.
From.
But you can see the
Yeah, here it will show you. When you hide the column header, you don't need to yeah. So let's just see what it has done. So it will not show you those columns because it's hidden.
This is what hidden does. Hidden doesn't have anything to do with the insert field. There is motion. Because now it's here, this Chandula, that name, manager name. Yeah. So ideally it should insert it to start line. But it has omitted those two.
Yeah.
right? Otherwise, she has using one. Essentially, after you have to open the corridor, after you create the head, because this corridor was open before creating the head. That's the if you open another corridor, then
Yeah, I think I should do that, otherwise everybody will get
just open
confused.
this little new corridor. See?
Still giving me.
Also, close like
Okay.
So now it didn't by default show me the start time and end time stuff because they were hidden. So now you can see that some values are filled there. So I entered this record today. So 10 means I think it's UTC time. It records that time, and this end time means up until which date this is valid. So by default it just gives you the maximum it can go. And let's have a look at the history table. So now you can see nothing's there, right? Because it doesn't record anything when I initially add something to this table. It will only record a version of this. In instances where you need to where you have these two columns, if they are not hidden, or if we have to somehow enter values to this, we have to give the default, we have to insert them as defaults, otherwise it will not allow you to do so. So let me insert like a couple more here.
You can put any specific date there, right?
No, we can try. It should give us an error.
Put the manager name into the list of rows.
So I have to do this, it does the same thing. Now if we go to the department and history things again, now both my records are there. So that's how you insert stuff to temporal tables. So it's not a big deal, right? I mean, nothing major happening here. We can, it's just like I'm writing a regular SQL query. So let's move on to how we do updates. Yeah, so when you're doing updates also, it's nothing major, it's the same thing. So you can just write a simple update query here. So I'm going to set the manager name to something else here. Okay, so I'll first do it just for one thing. Okay, so now if we go and see, because I changed the first record, it should record the older version somewhere in one of our tables specified, which is the history table. So I'll add the manager name here as well, so you can see. Okay, so I changed the manager name of this department to test user, and my old record is still there in our history table. So if you want to see at a given point who was the manager and what are the changes which have been made, we can do that. Do you have any questions? No? So So this is how it goes. So each time when we do a modification to this table, it will go and record new things in the history table. Sorry? Do you want me to change? Okay. So here, I hope you guys understood what I told earlier. So we are always, when we look at the history table, it's just a matter of for how long this record was valid. So it will tell you from these two columns, from what time up until which time this record was valid. So after this time, someone else has changed this record. Okay, so then we'll move on. So I told you that we use temporal tables to do like various things. I said data auditing and time traveling and stuff like that. So in order to do those things, this is the only different part as I see it, and that is also not a very big deal. So we can use, there are some keywords which we can use in order to query these tables. So the first one is between and. So if we want to, we can't, if we don't want to directly query the history table, that is not how it happens usually. Usually you go through your main table, and if you still want to see the historical data, you can use these keywords. So when you say select from department, it's very clear that you are not querying any history table here, you are just querying the department table. And you say for system time between whatever the time period you need. So here says 2015 January 1st to December 31st. And you can, these stuff are the normal things. The only extra part is here. So when the moment you specify this, it will actually check the history table as well. So let's just execute this and see the execution plan. So it obviously didn't give me anything because I don't have any data for that time. So here you can see that it's actually looking at both department and history tables. Okay. So similarly we have contained in clause. So this is also something like between, but when I read up, they have said if you purely want to query all data, which means you are going to query from the history table, then it's more efficient to use the contained in clause than using between and. So it's again similar, and if you want, you can just go ahead and this is all thing as well. So it will give you basically all the changes and the current versions of your department table. So I think I'll just show you one more thing and we can wrap this up. So I said we can also restore data from an older version. So in order to do that, we can use this this system for system as of clause and take take something from the history table and put that in our table. So let's try and do that. So I'm going to update the department table and set name as the history table's name from department blah blah blah, and I give the time here, and I have to give some condition here. So we anyway have to do this when writing normal update statements as well. So only thing which I will do is I will just check for a valid time here and enter it.
Give the exact time method in time. For the previous records, in time is the next record start time.
I think it should take the. I'm not sure. I haven't tried that, but I think it should take the. Hold on. So we'll see what this will do. So I selected this time. My manager name is test user, and I'm going to revert my. So my department name is IT. So I want to revert it back to the department name which was given at this time. So after I execute this query, hopefully the name should be changed to marketing. Let's go and see. So this is like a very basic, actually it's just a very slight, like very light introduction. You can do so many things with temporal tables, and I personally found it very helpful, and I always wondered like how people do this version tracking and stuff like that, and how complicated that is, like to maintain that kind of a thing. So with these kind of things, I think it's very easy. We don't have to worry about maintaining all these things. So I think we can finish off the presentation.